All right, welcome back. Today we are going to talk about section 7.5, which is solving trig equations. So we'll go ahead and jump right into this here. I'm going to go through a majority of slides from your notes. There are a few additional examples at the end that I probably won't get to on this video, but I will post the completed notes on Schoology so you can open up that file and see the last couple pages to complete your notes. So with that said, we'll get going. So our objective today is to solve trig equations and inequalities. So on that note, we'll get after it. First order of business is principal values of sine, cosine, and tangent. When you take the sine of a value or tangent of a value on your calculator, it is always going to default between negative 90 and positive 90. The reason for that, if you look at this little circle here to the right, sine value goes from negative 1 to 0 to positive 1. That happens from negative 90 to 90. Similarly, cosine does the same thing from 0 to 180. So we go from 1 to 0 to negative 1 with our cosine values from 0 to 180. And then obviously in third and fourth quadrant, they repeat. Just like up here for sine and tangent, all of our sine and tangent values repeat in second and third quadrant, same as they would in fourth and first. So your calculator will always default to these values. So if I need, for example, if I need a sine value in second quadrant, and it tells me, for example, negative 40 degrees, so negative 40 would be the same as 320, and if we go 180 to the other side of the circle, we can get those values for tangent and such. So that's how we work that out. We'll go through some examples and explain that in more detail as we go. All right, so our first equation here, you can see we have sine of x times cosine of x minus 1/2 of cosine equals 0. First thing hopefully you see here is both of these terms have a cosine, so we are going to factor that out. If I factor the cosine out, I am left with sine of x minus 1/2. Now that this is factored, I can set each one of those equal to 0. And at that point, we can now solve each one of these equations for the principal value, since that is stated in the problem. So we want to know where cosine is 0 between 0 and 180 degrees, and where sine, ultimately we're going to solve for sine, is equal to 1/2 between negative 90 and positive 90 degrees. So cosine equals 0 at 90 degrees. And if we look at our unit circle for where sine equals 1/2, that's going to be in first quadrant, and that happens at 30. If they ask for radians, we could do that. So we know that 90 degrees is pi over 2 in radians. We know that 30 degrees is pi over 6. Typically, if they don't specify in the question, we'll default to degrees. If it does say principal value in radians, then we'll give the radian value. As far as a quiz or test or assessment problem would go, either one of these answers, whether you give me in degrees or radians, would be acceptable. So again, we factored out the cosine. That gave us our two factors, set each factor equal to 0 and solve. Cosine is 0 at 90 degrees. Sine is 1/2 at 30. So when we solve these equations, you're going to get the usual suspects. We're going to get 1/2, we're going to get 0, square root of 3 over 2, square root of 2 over 2, 1, or negative 1. So those are the values that we will see when we do these problems. Okay, this one is a single term, so we don't have to factor this, but we will have to solve this for x. So I'm going to take and move the 1 over, and then I'm going to have to divide by the square root of 2. And you can see my work here to the right. If I rationalize that, that is square root of 2 over 2. Again, we're looking for the principal value of sine. So that's between negative 90 and positive 90. And for our purposes, sine is square root of 2 over 2 at 45 degrees, or if we're talking about radians, pi over 4. So again, I got the trig function by itself, move the 1 over, divide by square root of 2. I had to rationalize that. And again, our equation is solved at this point, then we are looking for the angle measure that makes that true. Again, principal values here. So for sine, that's between negative 90 and positive 90. If it was cosine, it'd be between 0 and 180. As I go through this, if you need to, feel free to pause or go back at any time. I know normally in class, obviously I would take the extended pause so you guys can write and process a little bit. But for the video purpose here, I'm limited in time and how long I can make these recordings. So I didn't want to, you don't want to sit here and look at my mug in dead silence. So, all right. For this next one here, you can see we're looking for the values between 0 and 2 pi. So now we're extending beyond the principal values. We're talking about the values all the way around the circle. So there's a good chance that we're going to have multiple answers here. You'll also see that we have cosine and sine. Fortunately for us, we know that sine squared plus cosine squared equals 1. And if I solve this really quick for sine squared, I know that sine squared is 1 minus cosine squared. So what I'm going to do is I am going to replace that sine squared with 1 minus cosine squared. The reason I'm going to do that is that gives me everything in terms of cosine now. So now I have all like terms. Just like if we had a quadratic, if we were dealing with x squared plus 5x plus 6 or something like that, we get everything over on one side. So that's what we're going to do here. We're going to move all the terms over to one side. So when I do that, I'm going to subtract this 1 and add cosine. These 1's are going to cancel out. I now end up with 2 cosine squared minus cosine equal to 0. Both these terms have a cosine, so I can factor cosine out. And now I have 2 factors that I can set equal to 0. So ultimately, we are looking for where does cosine equal 0 and where does cosine equal 1/2. Up here by our restriction, again, they want all the values between 0 and 2 pi. So this is telling me it has to be in radians. So I know that cosine, if I take a trip around the unit circle, cosine is 0 at 90 degrees and 270. They want that in radians. So that's really pi over 2 and 3 pi over 2. When I solve this second factor, cosine is 1/2. And I know that cosine is 1/2 at 60 degrees and again at 300 degrees. In terms of radians, that is pi over 3 and 5 pi over 3. So again, we set each factor equal to 0 and solve. You can certainly find the degree measures first, but ultimately, because of this restriction right here, 0 to 2 pi, our final answers need to be in radians. And so this is the 2 times that cosine equals 0 when we go around the circle, and these are the 2 answers where cosine equals 1/2 as we travel around from 0 to 2 pi. Okay, this is similar to the last problem, only now we're back to degrees. So this is why you've got to look at this restriction really close for each one. So last one was 0 to 2 pi, and now we got 0 to 360. You can see that both of these terms have a sign, so we're going to factor that sine of x out, like so. Just like our previous problems, set each factor equal to 0. So we want to know where does sine equal 0, and ultimately where does tangent equal positive 1. We know that sine is 0, our y value is 0 at 0 degrees and 180. And we know that tangent equals 1 at 45 degrees and 225. And how do we know that? Tangent is y over x, or sine over cosine. At 45 and 225, the sine and cosine values are the same, square root of 2 over 2. So if I take square root of 2 over 2 divided by square root of 2 over 2, we get 1. Again, that happens at 45 and 225. Always look at the restriction because that will tell you whether your answers are limited to a particular quadrant or the entire unit circle. One last caveat that they can make here. So we've had first quadrant or principal values. We've had 0 to 2 pi, we had 0 to 360. Now this one says for all real values. So that means forever, not just from 0 to 360, but to infinity. So how do we take care of all real values? Well, first of all, from a solving standpoint, we do it the same way that we've been doing. We're going to get everything on the same side. So I'm going to subtract that square root of 3 tangent of x. Now that I have tangent in both terms, I'm going to factor that out. And now that I have both of my factors equal to 0, I can solve. So we want to know, where does tangent equal 0? And where does tangent equal the square root of 3 over 3? Now, that one's going to be a little bit more work, but we'll take care of that. So where does tangent equal 0? That is when y over x equals 0. So that happens at 0, and it also happens at 180, or 0 and pi, if you will. And so we have every value. I'm going to start with this first one here, so let me move this over. So every value of tangent where it's 0, that's 0 plus 2 pi k, so 0, 2 pi, 4 pi, 5 pi, or pi plus 2 pi k, so 1 pi, 3 pi, 5 pi, 7 pi, and that takes care of all those values. Now, if you happen to say that in degrees, because they didn't specify, then we would add 360. So you can see here, if you chose degrees instead, it would be 0 plus 360k, 180 plus 360k. So again, that's every multiple of 0 and pi, or every multiple of 0 and 180. We keep getting back to these 2 points where tangent is 0. The second one here, a little bit more developed, because we want to know where tangent is square root of 3 over 3. So in other words, where does y over x equal that? That's going to happen when our y value is 1/2 and our x value is square root of 3 over 2. Because if I simplify this, I get 1 over the square root of 3. And if I rationalize that, there's my tangent value. Square root of 3 over 3, that's where I'm looking for. So again, that happens when y is 1/2 and x is square root of 3 over 2. So where does that happen? That happens at 30 degrees in quadrant 1 and 210 over in quadrant 3, because tangent is only positive in quadrants 1 and 3. Excuse me. Again, you have the choice. You can say this in terms of radians. So if I do radians, I got pi over 6 and 7 pi over 6. Again, I'm going to keep adding 2 pi, so I keep getting back to that same spot each time. Or if you say it in terms of degrees, we add 360. So 30 plus 360k, 210 plus 360k. So just a quick review on this one. You've got to solve, factor the tangent out and solve. And then you want to know where tangent is 0 and where tangent is square root of 3 over 3. So you're going to have to look at your unit circle and your x and y values for that in order for that to happen. Okay, here we are trying to solve for x again. I am going to replace secant squared. I know based from my Pythagorean identities that secant squared is 1 plus tangent. Now I have everything in terms of tangent, so I can distribute. And we are going to set this equation equal to 0. Once I get to that point, I can factor. So there's my factoring, and then I can set each one equal to 0. And I'm going to scroll this down here. I'm pushing up against the clock here, but so basically we want to know where tangent equals square root of 3 and where it equals positive or square root of -1, which is undefined. So here's my two values right there.